The hope for today's presentation is to give you the basics to get started with routing using pipe and tube. A lot of you will have the routing add-in, maybe have never attempted it, are doing things in a more old-fashioned way, maybe using sweeps or not modeling in some of the tube, pipe, or electrical pieces. We're going to focus today on just pipe and tube and look at really the areas in which you need to get started and understand the SOLIDWORKS software a little better in order to take advantage of routing using pipe and tube. Before we get started, I have just a couple basic questions for the group online here. First of all, I just want to get an idea of who's attended Lunch and Learns previously, just to see what the cross-section is here. All right. Give a few more seconds to vote here, and I'll just share those results. So for those of you who have not attended Lunch and Learns, our focus for these sessions are really to pick a topic and to dive in a little deeper than maybe the training manuals or the help does, and look at very specific areas, and hopefully you pick up a tip or a trick or something new to kind of take into your everyday job. Now in the Lunch and Learns, it will be me talking a majority of the time, but if you have any questions, there is a question section of the GoToWebinar window. Please feel free to post any questions there. At the end of the session, I will go back to those questions and answer those before we get offline here today. Now, a couple other questions here. Get an idea of what type of routes are you looking to create within your product. As I said, we're focused today on pipe and tube. You can pick multiple pieces. I just want to kind of get a cross-section of what people are doing for the most part. Give a few more seconds to vote. All right, just to share that with you. Looks like we do have a lot of folks doing electrical routing. The great thing is, even with today's presentation, the basics and fundamentals that we're going to show you for pipe and tube all cross over to doing electrical routing and wire harness design using routing as well. A couple other questions here. For those of you who have used the routing add-on, what has your usage been? I'm trying to get an idea. Do we have new users, never used, that kind of thing, just to give an idea of who we have online here. And it looks like I have the right audience here. I'm going to go ahead and close this and just show everyone. This is really where we're focused with this group. For those of you who never used it or light usage, we're going to talk about the basics here. Thank you. Last question. I just want to find out, for those of you who have pipe and tube in your assemblies or electrical, are you modeling it in? And if you are using sweeps, really it should be, are you modeling it in at all? So if you could go ahead and just vote, just get an idea. Okay. So some of you are not modeling it in, some of you are. Again, hopefully this will give you some excuse me, guidance going forward as far as which approach you might want to take to this. All right, so what we're going to talk about today with the fundamentals of routing, I've kind of broken up into 8 different sections to really set the stage for what we're going to do here. We'll talk about the basics, go over some terminology. It's important, especially when starting with this product, to understand, what are we even talking about here. There's some other fundamentals that we need to understand, internal versus external components in SOLIDWORKS. We need to know how that works. The routing setup, how do we get it going? A little bit about where to get the routing settings. We'll go through some of those, and then we'll route some pipe, route some tube, and then finally we'll finish everything off with a basic look on how to create components. So let's start with the basics. There's really 4 main areas that you have to be strong in order to get comfortable using the routing package. First of all, you must be able to understand and create configurations of models. The routing package takes advantage of the ability to have one model that has multiple sizes. Okay, I'm going to show more of that as we go through. Now, because we typically route inside of an assembly, you have to be very comfortable with top-down design, editing parts inside of assembly, jumping back and forth between different levels. And I'm going to go through a little bit of that. There's this aspect of your design library using your task pane. Comfortable using that, taking advantage of that. And then 3D sketching. So let's just pop back to my SOLIDWORKS here for a moment. Let me go ahead and launch it. And we're going to just launch a sample assembly to get started with here. Now, the first aspect of this that we want to talk about is the usage of configurations. Now, I'm using SOLIDWORKS 2014, so some of this is going to be new for 2014, but I will point out the differences. First of all, in 2014, when you have multiple configurations of a component, in this case it happens to be threaded steel tube T-fitting, you'll have the ability to make those selections in the graphics area. If you're just getting into routing now, you're really going to have to get a stronghold as to how to create configurations. Configurations being the ability to have multiple sizes of a component in a single file. In this case, I have a T that has multiple sizes that it can accommodate for threaded tube. Now, along with that, you will want to brush yourself up on the ability to create design tables. This is definitely a big factor when creating components for routing, as they use a lot of different parameters to help automate what goes on here. Now, that being said, the components that I'm using today are all out of the standard library, and we'll talk a little bit about that. If you're just getting ready to start routing for the first time, I would suggest go through the tutorials and maybe brush up a little bit on your design tables, and that will kind of help you get going. Now, the other part of this is the ability to understand top-down design. And just to kind of start with the basics here, let's say I was going to edit this particular frame inside the assembly. When I click on the component, I have the option to edit the part. And what this would do is change the way we work inside the assembly. If you're not used to working top-down, there are some settings and things you need to be concerned with and understand. First of all, I know that I'm editing this component because, first of all, my graphics area only shows that component visually, but also that the component I'm editing is actually in a different color in the feature tree. Now, some of these things can be affected by settings inside the assembly. So if I set this to opaque, I can look at this and say, well, you know, maybe I'm not editing something. So the visual cues are a little bit less obvious, I guess I would say. You will have a symbol in your confirmation corner inside of SOLIDWORKS to let you know that you are also editing a part. Now, the opposite of editing a part is editing the assembly. So bouncing back and forth can be done through the right click or turning on and off the edit component command. So very important with routing to be able to bounce between the different things. Now also, in your task pane, the series of tabs off to the right, one of those is the design library. And I find that, you know, maybe, excuse me, there's not a lot of companies utilizing the design library to its potential or at all with the ability to reuse components. Well, routing is very, very tied to the design library. Here we have the ability to get to the components we want to add, whether electrical, pipe, or tube, and we're going to use a lot of drag and drop functionality in here. So you may want to brush up on your design library with this as well, the ability to add library locations and make sure that all your components are listed there. Again, what I'm using is out-of-the-box design library with everything that you would see during a typical install of routing. That being said, under routing in the design library is a tab for SOLIDWORKS content. And if I were to select that, there is a routing section in here where you can actually download libraries of routing components. These are all available just by going to the particular standard that you want, holding down control and downloading this entire zip file and extracting it. So there are some libraries that are available, but you will have to know how to use the design library to kind of work with that. Now the third and final piece that's going to become very important to working inside of routing is the concept of 3D sketching. Now we're used to daily sketching on 2D planes and surfaces in our solid models, but in some cases, in all cases in routing, we want to create a 3D sketch. Now the 3D sketch removes the limitation of not being able to draw something off of a plane. Now I'm just going to start a 3D sketch here just to show some techniques. You're going to use a lot of the typical tools, lines, arcs, radiuses, things like that, except we'll now be presented with a set of axes in your graphics area. And notice my cursor now tells me the directions or the planar directions that I'm able to draw in. For instance, if I wanted to draw up in the Y direction, I can now draw my line. Some of the relations that you'll see in 3D sketching are going to be different. This isn't a long Y relationship. In other words, my line is now going in the Y direction. Now, if I want to draw in the Z direction, sometimes you get confused and you start to just kind of drag the line out. It looks like it's in Z. I'm going to go ahead and drop that there and rotate, and look what I actually did. I've actually only drawn on that existing plane. So one of the things that you have to do is use your tab key. Tab key switches between the available planar directions or axes to use, and now I can draw, in this case, along Z, and if I rotate this thing, you can see that this thing is along in a different direction. Now, drawing in 3D space kind of messes with your mind a little bit as far as orientation. One of the things that I really like to do to facilitate that, if you go to your window menu and go to viewport, set it to a 4 view. Now what this allows you to do is not only see the isometric, but also see the X, Y, and Z directions. So if I wanted to come in here and from the Z I wanted to come down a little bit in the Y, I could come up to the top section, and you'll notice how I can see that isometrically. Okay, I want to come down in the Y, then maybe I want to drag off in the X direction. I can come over. Notice how things switch when I go from this viewport, it's YZ. This viewport automatically goes to the XY, and I can easily just come over in the X. But what's great is I can visualize it in 3D because I have the trimetric view in the corner, but I also have all the elevations, so now I can start to take a look at what I'm dealing with as far as elevations as well. Okay, so for routing, those 4 fundamentals, if it's something you're going to take on, I would brush up through the tutorials on those fundamentals with routing just to make sure that you have what you need going forward. Okay. Now, a little bit about terminology, and I'll illustrate this using an example here, but with routing, when you're talking to someone about all the different pieces, there's a lot to talk about. Well, what is a route? What are route parts versus route components? What are connection points versus route points? Your feature manager changes a little bit. So let's take a look at that inside of SOLIDWORKS for a moment. First thing to talk about is what is a route. Now when I look at assemblies inside of SOLIDWORKS, we're used to the typical assembly icon. That assembly icon has a part with a green component on top of it. When you're dealing with a route, you're going to see a piece of squiggly tube over the top of it. The route really is all the fittings, pipe or tube, all in one. It's fitting to fitting, flange to flange. It contains everything for a run, called a route. Now, the route, if I expand it in the feature tree, is going to be made up of two folders. One being route components. Now, route components are things like elbows, T's, flanges, and then there's a section called route parts. Now, route parts are parts that are created automatically by using the routing add-in. These are typically tube and pipe pieces. Okay, so in my case, if I expand route parts, these are just the pieces of tube and pipe in this steel pipe run that I have there. With that comes the idea of control points. Now I'm just going to open up the fitting that I had here, and you'll look at the feature tree, and there's a series of sketches and features that belong specifically to routing. One is called a connection point, the other one is called a route point. Now, what a connection point is it tells routing the direction in which a piece of pipe comes in and how far that piece of pipe comes in. So the point at which it starts and the direction, the normal direction it comes out this end. And you'll notice on a T, I actually have 3 connection points coming out of the T fitting. Now, what a routing point is, it's a central point that when this T is drag and dropped into SOLIDWORKS to create a route, that point gets locked to the point that you drag it to. And we're going to show this stuff live. So all of our fittings, all of our inline valves, all of our flanges, really everything that we add to a route inside of routed systems has these connection points and route points. So there's some intelligence that has to be added. Now, the libraries and the stuff that I'm using today all has that intelligence built right into it. Okay. Now, the route itself, if you expand it, I talked about components and route parts, but you'll notice there are no mates associated with this. As we go through and start creating routes, we're going to talk a little bit more about why that is. But everything is built in position, therefore there are no mates. Underneath that, you will find a feature called Route. This contains the physical 3D sketch that was used to position and locate the components on the route. Okay, so the feature manager look underneath any kind of route is going to look like this, where you have components and route parts. You have a route that represents the sketch that was used to create it. And then also notice one of the things you're going to want to get used to is changing your tree display. In this case, I'm actually looking at the tree display and it's showing me the configuration that's being used. And as part of routing, it's also showing me the distance or length of that piece of pipe. Now that's controlled inside of SOLIDWORKS under tree display. So I can turn on and off whether I want it to show the configuration name, component names, or display state. I like to keep it under component names and configuration, especially with routing because we're using a lot of different configurations of components. Okay, so all of these are going to go to better understand what's going to happen inside of, that's my fault, inside of routing. Okay, so the next conversation we need to have is related to internal versus external components, something SOLIDWORKS calls virtual components. Well, virtual components are taken advantage of by routed systems because of a few things. First of all, they're easy to manage. If a file is virtual, That means there is no file that you actually manage on the hard drive. All the data is embedded within the assembly so that you don't have to manage individual pieces of pipe. Now, it makes it easy to rename. When you create them, it does some automatic naming so that it creates an intelligence so you understand. Now, what we need to understand is how to look at which parts are virtual or internal versus external. So let's just bounce back to SOLIDWORKS just for a moment here. And if I look at the route that we were just talking about and go through the listing, you'll notice that these components here, which are the elbows and the T's, don't have the same syntax of naming that the route parts do. And more specifically, what I'm looking at is this set of brackets that are around the name. Okay, so copy of 75 pipe with the set of brackets around it. That set of brackets lets me know that that particular piece of pipe, in this case, that length of pipe at the very end, is virtual. It is contained within the assembly only. Now, I have the ability, when it's a virtual component, to actually save that part in an external file. Now, let's use an example other than a route for a moment. If I decide to insert a component into the assembly, it asks me, maybe where I want to place it. Insert a new part. Select the face that I want to place it to. You'll notice that even my new part has these brackets in it. That is because inside of SOLIDWORKS, under my tools options, under assemblies, there's an option to save new components externally. If I turn this on, it's automatically going to try to save this to my hard drive as a new component. But with it off, it becomes a virtual component that I can now draw and create inside the assembly. Let's just create some sort of feature here. Now, once I have that component created, and it is virtual, if I want to save it outside the assembly, I can say save an external file. There's a path. I just give it a path. In this case, we'll put it on my desktop. And once you say OK, the set of brackets now gets removed, and the name that I give it in the save as becomes traditional like we're used to. You're also going to have the ability in SOLIDWORKS to make components that are saved on the hard drive to make them virtual. So now this thing exists on my desktop. I want to virtualize it and embed it in this assembly. It's always going to tell you it's going to break the link to the external file, and now that gets that set of brackets in there to let me know that it's virtual. So for routing, you need to be able to look at the feature tree and understand whether a component is virtual, okay, or whether it's external to a particular assembly. This is an important concept that you'll have to understand going forward. A couple other things. Easy to rename. If something is virtual, you can right-click on it and just say rename part. I can call this, let's say, bracket. When I call it bracket, it's always going to have an added section to the name because it automatically appends the assembly name to the name. So it's bracket at the pivoting conveyor frame because it's embedded in this pivoting conveyor. Okay, so this is a concept that will be utilized quite extensively with routing. Now let's talk a little bit about routing setup. The first thing there is with routing setup is to talk about the routing library, and I talked a little bit about the design library, but there's actually another method that we want to talk about for setting up and working with the libraries. First of all, getting going with routing, you're going to want to go to your add-ins and turn on your SOLIDWORKS routing. And when you do, you should end up with 3 more tabs on your command manager. The software isolates commands that are specific to electrical runs, piping runs, and tubing. And you'll also end up with a pull-down menu. Now, in that pull-down menu, you're going to find a section called Routing Tools. And once you have or start routing for the first time, you're going to want to go to something we call the Routing Library Manager. This is really the tool that you're going to use to set up all of your libraries, to set up the properties and information, as well as create custom components. Everything is going to really be done through here. Now, to start with, the first thing we want to just to make sure everything is going to work the way I want it to work, you're going to go to the tab called Routing File Locations and Settings. Now, in your company, if you're creating a routing library, you're going to want this to be in your PDM system or on your network. So you're going to want to move this out to a server. So this interface that I'm showing you here allows you to point to what that routing library is or where it's located. Now, you have to work out of that library, because if you start dragging, dropping components that are outside of this path, it's not going to work the same way. It's not going to prompt you for certain things. So you want to set up your library. Now, just like in SOLIDWORKS there's templates for a route as well, setting your units, setting your excuse me, properties associated with that. And then it breaks out the different sections, which we're going to talk a little bit more about. These are specific areas of pipe and tube and electrical cabling that we can isolate here. Also, what units are you working in? So you're going to want to make sure, at the very least, that this path matches, and that these paths, in this case, it's automatically looking for these XML files located in this path. But it's called your Routing Library Manager. Now, one other way to get to that, if you go to your Start, All Programs, go down to your SOLIDWORKS, under SOLIDWORKS Tools, in there you will find the Routing Library Manager as well. Okay. It's going to be the first place to go once you turn it on. The next thing we need to talk about is routing settings. Just like when we create a drawing, there's numerous amounts of settings that affect how our drawing reacts to when we place views on there. There's the same thing for routing. And some of them give you very different results as far as how you interact with the software. It is located in Tools Options, System Options. Now, unless you have routing on, you will not see this section here. Okay, once the add-in is turned on, you will have the ability to get to it. First thing I want to point out, there's a section called Routing File Locations. You'll notice that there's nothing I can set in here, but I can launch the Routing Manager. What we're really focused on is the routing settings listed under the main header. And all of these are kind of a mix mash of commands that can be used generally, and then ones that are specific to pipe and tube, and ones that are specific to electrical. Now, I'm going to show a few of these just to highlight a few of that you're going to probably work with initially. When you drag and drop components, the ability to rotate them by a particular angular dimension or a number of degrees can be set here. Also, positioning them using a triad on drag and drop, that's set here as well. Now, this one, automatically route on drop of flanges and connectors. I'm going to have this on, and then I'm going to, let's start off with, we'll actually turn it off to start with. We'll talk about the differences. By default, it is on, but I want to show you what it looks like when it's off. And the last important one that I want to focus on is route error checking. So when you're running a route, if there's a problem with an elbow, if there's a bend radius on a piece of tube that exceeds the maximum bend radius of the tube, this option is what does that check and tells you that there's an error. Okay, so let's just keep things as they are, but I wanted to just point out that there are a series of settings for routing that will affect how we work. So let's go ahead and get started running some pipe. Now there's a lot of options and there's no way we can cover these all in a lunch and learn, but the basics are all the same regardless of what we're doing. So how do we run a route and get started? With pipe, we can create weld gaps. We have the ability to remove pipe and change diameters, add components, middle of the route. We can add coverings. So if you have some sort of tape or insulation type covering around your pipe, we can add that as well. We have tools to replace fittings. There's a lot of different parameters that we can kind of deal with, but I want to get through the basics here. So we're going to get out of this example. Let's go to one that, let's see, this one here. What I have is just a very simple example as to how to get started here. First thing we're going to do is we want to set up our connections between equipment. Now, how this is laid out, this is just standard SOLIDWORKS. Something was placed in and patterned and rotated, and that's all this is. So we've set up the equipment that we're routing to and from. The next thing I have to do is to start creating the pipe route. Now, in your design library, you're probably going to want to pin this thing up to get started. And I'm going to go to my routing library, go to the folder that's specific to what you're trying to do, and there you'll find the different classifications of components. We're always going to start possibly with a flange here, and I want to drag and drop a flange. Now it uses SmartMates in the components to drag and drop and mate itself to the existing equipment. Now here's why we have to really understand configurations. Because that flange, when I drag it in there, has multiple sizes of 2-inch flanges that match the equipment. Okay? By selecting one of those other sizes, it's going to swap out the configuration. Now, if you want to go with a bigger configuration, I can list them all. You can see there's 50 to 100 of those here. But this is actually reading some information from the equipment so that it knows this is a 2-inch route that we're placing on here. Now notice when I say OK to this, nothing started, routing didn't happen. But what you do see is the connection point and the routing point for the flange that I placed in. Now you can turn those on and off under the view menu. You can turn on and off routing points. It's also in your view pull down. But we're going to need those here in a moment. Now if I go over here, I can place the other flange in and pick the flange size that I want. But again, nothing has happened. My routing add-in is on. It didn't prompt me to do anything. To get started using this method, I have to go to one of the connection points, right-click on it, and you're going to find an option to start the route. Okay? Now, when I select Start Route, the first place it launches you is the Route Properties dialog. This is really where I specify things like the piece of pipe that we're using, the configuration of the pipe, the elbow that I'm using, and what limitations I have to the types of components. Now, let's start at the top here. What a route specification is, a spec is the ability to create a template that tells the user we can only use these types of pipes in this design. So you can create a spec ahead of time so that it only picks 2-inch Schedule 40 pipe for this particular run. And this could be a pull-down menu. In this case, I'm just going to turn that right off. Okay, I will show you how to create a pipe spec. With that off, I now have the ability to change the configuration. But notice, because I'm adding it to a 2-inch fitting, that I'm only capable of selecting the 2-inch pipe with the different weight ratings, schedule ratings for that pipe. So if I want schedule 40, it shows me the wall thickness. Now if I'm using weld gaps between them, I can turn that on. If my pipe comes in standard lengths, think of if you're piping a building and a pipe run's going to be 150 feet. Of course, you're not going to get a piece of pipe in 150 feet. You'll get it in 10 or 20 foot lengths. So here you can say, use a standard length. My standard length is X number, and then when you connect them together, use a coupling, and what's the coupling that you're going to use. So there's some options to automate that work. In this case, we're not going to do that. Now, elbows. What elbow part am I going to use? And again, it's looking into my library for my piping elbows. And again, it eliminated any wrong sizes and give me the schedules available for that as well. If there's a covering around the pipe, we're going to have the ability to add our coverings, and I'll show you a little bit later. In this case, tape, rope, adhesive tape, the different types of rope that we have. There could be insulation. You can actually create and add your coverings to this as well. Okay. Now, down at the bottom, you can see that it's actually showing me where my routing library is. And this is important because these parts are coming out of here automatically so that it understands where it's getting the parts that it's going to use. Now, once I accept this, a bunch of things happen. First of all, your new route will be created in your feature tree. Okay. You'll notice that there's a route sketch already created within it. I can now, as I'm working, editing a subassembly, I can now go to another fitting, and you're going to find an option, Add to Route, which will now add that particular segment to the route as well. This is the point where you would use 3D sketching to sketch the path that you want to use to go from this point to this point. Now, these lengths of lines, we call these stub links. These are defined in the component itself, but since the endpoint is undefined, I can actually drag these lengths out a little bit to specify a length. I can also add a dimension. Maybe I knew the distance I want this to come out straight is 10 inches. Now, like I said, I can connect this with a sketch, but there's also another option called AutoRoute. If I right-click on a point within the route, there's an option to AutoRoute that allows me to select a second point or multiple points in which I'm going to connect it to. Now, this AutoRoute tool has multiple selection options in it. We're focusing right now on the original AutoRoute, which provides me a orthogonal path XYZ direction from one point to another. If you don't like the path that was created, you can actually see alternate paths. In this case, this goes in the Z first, then X, then the Y, then the Z, or Z and Y. Okay, and this will route between the components. Now, as you're routing, you're actually going to be in sketch mode. You're editing this 3D sketch. So you'll notice I have Edit Sketch up here. Once I exit out of Edit Sketch for the very first time, that's when those two folders get created. Okay. If I expand components, it actually created the elbows in there. Now, first thing I want you to notice about the components is that they're not virtual. That means that this component is saved to the hard drive somewhere. Because it was a library component, it actually went and used the same elbow from the library. Okay, it's not virtual. If I expand the route parts, you'll notice that I have a bunch of virtual components. These are being the segments of pipe. Now what routing does when it creates pipe and tube is it goes to a component out of the library. In this case, let me just show you a piece called pipe, and it will make a copy of that virtually, and it creates a virtual component with that length for each pipe length. Now if I expand my tree out a little bit further, you'll also notice you get the length dimension for each piece of pipe. Now where this is beneficial is I no longer have to manage every little piece and length of pipe. Okay, these are all virtual, so think of a pipe run that might have 10 or 20 or 30 pieces of pipe that need to be cut. I don't want to have to manage those files on my hard drive, and that's where virtual components play a huge role. You'll notice here that the display state is showing. You can see how long this message kind of gets. That's why I was talking about tree display, turning off things like display state names so it's a little bit clearer. I'm seeing that I'm using 2-inch schedule 40 pipe at 20 3/4 inches in length, and when I select it, I can see graphically what I'm dealing with. Now you'll also notice once I've exited the sketch, the components will show up in their proper color, yellow being your elbows, purple being your pipe, but I can also see all the connection points and route points for each component. Again, you may want to go to your pull down menu and turn those off so visually you can see that. Now one thing is missing from what I just did. The 2 slip-on flanges that we started with are now outside of the subassembly. They're not part of this pipe. You can see that when I select it, the flanges aren't selected. A lot of times when you're documenting a pipe or a spool, you want the flanges shown as well. Now, one of the things I can do, and this is just SOLIDWORKS functionality, I can drag the flanges into the folder. Now, I need to be editing the upper level assembly. I just drag it in one at a time, and it will also require me to drag it into the components folder so I keep it organized. Now the first question is, well, why did that happen? Why should I have to do all that? I started with the flanges and kind of moved from there, and this is really set up because I set a particular option in routing. There's one called automatically route on drop of flanges and connectors. Now by default this is on. I want to show you how that works when it is on, because it does help you. Let's say I'm creating another route from this tank to this tank, and we're going to add in a third tank. I can go to my flanges, drag my first flange in. It's going to snap into position. I pick my size, same way as we did before. But look what pops up as soon as I do that. As soon as I do that, my route properties comes up where I can select the configuration of pipe that I'm going to use, elbow, and coverings. As soon as I accept that, we're already to the point where we're starting a route. Okay? If I expand that route that was created in the feature tree now, you'll notice that there's already a components folder that contains the slip-on weld flange. Okay? So now, as I'm adding other flanges, okay, it's automatically going to add it to the components folder, and it's going to automatically put a stub length out of each. I can go ahead and auto route between the two and get what I'm looking for. Okay, let's use that one there. Okay, so once I have that, and exit the sketch, you can see that each component is exactly as we talked before. Now, in cases that you've created a route and you want to edit the route to make some adjustments, we always go to editing the route, the actual sketch part of it, through the route sketch itself. Now, one way to get to that is just to right-click where it says Route, and there's an option to edit the route. This brings you right back into 3D sketch mode. In this case, you're going to still be able to see the components. I can, from here, go ahead and start dragging and dropping new components into the route if I desire. Now you can see in this case that I've added a new component. I can now tell the software through relationships that those two lines are going to touch each other. Now in this case, in order to create this connection, I would have to have another fitting. And because of the different classifications of components, in this case a T, I can go ahead and drag maybe a straight T, and notice what it does. As soon as I drag it over that point, it snaps to it. If you look at the center of my graphics area, you have an R point in the center. Now I introduced R points early on in this, but R points are what's going to snap to the point that you're dropping it on. Okay. Now I do have the ability after the fact to rotate the components if I want to, but in this case I don't need to. Now what if I wanted to add a different fitting in here where I don't have a point? Now one of the options that you do have on your right click is the ability to split the route. Splitting the route allows you to create a point somewhere along the route. At that point you can drag in other components. I actually have a ball valve that I can drag directly onto that. And what I'm really doing by creating that point is give it something for the R point to snap to. Now once it's dropped in, this axis that you see here is going to allow me to do things like rotate it. Now let me pick this here. Try to get my component here. No, that's not what I'm looking for. We're going to actually delete the fitting here. Okay, let's edit my route. Alright, so what we're going to do is just drag the fitting in again. I want to just show you something here. This set of axes that we have here is going to allow us to do some rotation of the fitting while it's in this edit mode. Rotating it by a specific increment. There's also shortcuts on your keyboard to do this. Alt or Tab key will rotate about that increment you specified, and the Shift arrow keys will rotate by that as well. Okay, so here I have my route, and when I exit out, everything is organized as it should be in my feature tree. Now, I talked about understanding whether you're in edit component, edit assembly. Now, even though you can see my route, I'm still editing the route assembly. So in order to go back up to the next level and create another route, I have to exit edit assembly mode, and that gets me all the way back up to the upper level. Notice nothing is blue, and now I have a route that's available to me. Now, a couple of the things that we can do with a route once it's here. You do have the ability, if you right-click on a route, to export the pipe and tube data. Now, this data can be exported, for instance, in PCF format to programs like Isogen that will allow you to do Isogen drawings. You can tell it where to export, what the file is, zip it up, and email it directly from this as well. If you're not using a product like Isogen to create drawings, on the piping toolbar is a pipe drawing tool where you can pick which pipe that you want to create a drawing of. Now, first thing it says is this assembly is virtual. In order to create a drawing from something virtual, you have to save it externally. Now, I'm not saving all the components externally. I'm saving just the assembly. In this case, I will go to my desktop and save that externally, and now I'm able to get to the portion of being able to open a subassembly that contains all of my components. You have the same kind of control here, turning on and off your R points and your C points. But now I have an option to create drawings. I can give it the sheet format and the bill of material that I want to use. And when I accept this, the software is going to automatically create a ISO drawing for me. Now it tells me there's no length field on my bill of material for pipes. Would you like to add it? So I can actually automate the creation of some of these length fields as well. So it gives you some scale that we're dealing with here. If I zoom in a little bit, it's ballooned. The ISO drawing, it has dimensions for each segment, the radiuses and distances that are available. Everything is ballooned properly, as well as having a bill of material with all the information as well and quantities. Notice the 2-inch Schedule 40 pipe is now also compiled into a total length. Instead of using individual lengths, it totals it up for you. So there's some automation built into routing. So everything that we've talked about at this point automates the creation of the routes. However, there is some other things that you can do to a route that you'll find on your right-click. I'm just going to show a little bit of these. For instance, adding a covering. Let's say this particular segment that I'm over, we want to add a covering. In this case, maybe rope, tape, what size rope, maybe a ceramic fiber rope. These are all coming from libraries. And I'll show you in the Routing Library Manager where you can add those. But you'll notice when I do add a covering that it actually does create this thickness around the pipe itself in kind of a different way. We also have the ability, let me see if I can find one that I want to remove pipe here. Let's exit out here. I want to edit this route. Okay, let's say I didn't want this pipe segment anymore. One of the things I can do is remove pipe. Now this one over defines it. Yeah, because my sketch is all locked in. Where it would have to stretch the segment. Because my sketch is all fully defined, that's going to over define it, but typically you're able to remove a piece of pipe which will stretch your lines and make that happen. Also, if I needed a gap for welding, I can add those individually, where I can create weld gaps, specify a distance for the weld gap, and it will actually create those in the areas that you need a weld gap. So all these things can be done individually using your right click, including the ability to add slope to your weldments as well. I'm sorry, into your pipe routes. Okay, so now I think you see where everything kind of comes together, where what you need to know is translated into a route, in understanding how that route is organized, understanding how to get in and out of assemblies. Let's talk a little bit about tube, because everything else is really very similar at this point. For tubing, we're just using different fittings, different types of fittings. You can see there's a bunch of compression fittings that we have here. Same concept, we're going to go ahead and drag and drop the fitting in. If we want to pick the configuration that we want to use, we can go ahead and do that. Now we're going to get properties associated with the route. In this case, we're using a piece of tube instead of a hard run piece of pipe. Now, in the end here, we'll talk about what that means, but what elbows are going to be used, everything along the way. Now, the only thing I want to show that's different here, let's put the other fitting in, is with flexible tube, there's really one variation. Well, this could be copper tubing where you're bending it into shape, but it can also be bent tube like rubber tubing. When I go to AutoRoute, one of the options that we have is orthogonal route, and when I get the tube, I can actually turn off orthogonal route and show a bent piece of tube in this case. Now, this acts a little bit different. I still have the ability to adjust, but this is a spline that I can control. It has some added capabilities. Watch as I drag this length a little too short. When I've exceeded the bend radius of that piece of tube, which is all stored in the configuration and design tables, it now alerts me that that has happened as well. Everything else associated with a piece of tube is exactly the same way as you do it with a piece of hard run pipe. You drag and drop fittings, you have R points and C points, and all the other controls are the same. Very similar in nature is the fact that tubing also has tube drawings. It also has coverings. All these things are part of that. The way that it stores components is the same, components and route parts. So once you learn how to do one, they're all the same. And electrical actually would be included in that conversation. Okay, so back to my PowerPoint for a moment. The last thing I really want to talk about is how do I add other things to the library. You'll find out when you turn on routing that the library has some things in there, but you're more than likely going to go out to GrabCAD, 3D Content Central, or model your own components like valve and inline, inline items and things that you might even already have them modeled. But how do I get them set up so that they're supported in routing? Now, first of all, there is a component wizard, which I'm going to take you through. It will handle just single parts, multi-body parts, assemblies. But first thing we need to understand is what's required. Okay, what is required for this geometry? Now, let's go back to SOLIDWORKS for a moment. And I'm just going to go to the help file. Let's do required geometry. Type that in. And I want to sort by location. Let's go to routing. When you're creating these different types of things, for instance, pipe, pieces of pipe sections, the software has very good help to tell you what needs to be in the default part that you're going to use. It's very specific. So for a piece of pipe, I need a sketch that's one of the dimensions is inner diameter, outer diameter. It needs to be extruded. It needs to have another sketch that specifies the diameter, and then you're creating configurations of that. If I'm creating a flange, I need an axis of rotation. There's some things that are required in the individual components. Well, how do I set up everything I need inside the components? Well, first thing is we're going to go back to our library manager for a moment. Okay, in this library manager is a tool called the Routing Component Wizard. Now, the component I want to add to the library is just a coupling. Okay, it's created as a revolve. The dimensions are all listed out, so I can easily create a design table and have multiple variations of sizes. But I need to set it up with the connection points for routing. Now, if we select the type of component it is, this one happens to be for piping. What type of fitting is it? In this case, other fittings. It's a couple or a union. Okay. And then it tells me what I need to have to make this useful for routing. I need to have 2 or more connection points. I need 1 R point. Now, if I select Add in here, it actually takes me right into SOLIDWORKS with the ability to create this point. Now, all I have to do in this case is pick a direction. It's going to pick the center of this circular face. I then tell it what the default piece of pipe that comes out using this configuration. And I can actually pick from a piece of pipe in my library. Okay, so this is half-inch pipe. I can specify, when I drag and drop them in, it created that straight length of pipe. I can specify what they call stub length is. If you don't specify it, it's just going to calculate it based upon the route diameter. Okay, so I create one of those. So there's one present. I have to add a second one, in this case on the other side, picking the same face and the same piece of pipe. And the next thing I need to do is add a route point, which is going to be used to drag and drop. Now in this case, if I don't have a point in the center, I got to create one, but I have created this such that the origin is in the center, and that's where my route point will be. Once I have everything I need, I have everything to kind of move forward in the component wizard. The last thing I need to give it is a axis. Now for this particular component, the axis isn't critical because it's not asymmetric. But if you had maybe a T where you had a reducing T, you want to tell it what the vertical axis of the component is. In this case, I can actually tell it to create a new one, and I could just use two planes inside the software to create an axis, and that will add what it needs. Now this wizard, you just keep kind of working your way through. It tells you if there's any missing items. So I told you there was some required geometry for pipe and tube. If some things are missing, this will tell you here. So if there was no nominal sketch or anything like that. And then configurations in file properties. I can add those individually here. There's also the ability to add properties that are going to isogen in here as well. Okay, and then the very end part is the ability to save it to the library. You tell it where you want it to go and hit finish, and now you've just saved that coupling into the library. So everything is kind of automated to help you to do that. Okay, we could probably spend an entire session just on creating proper components. The wizard makes it very easy to do, and you want to share your libraries so that everyone gets access to those. I think it's important to take advantage of what SOLIDWORKS has, but I think more than likely you're going to create your libraries on the fly as you go. And as you can see by that wizard, it makes it easy for any inline components to do that. Now let's go back to my PowerPoint here. That's all I had for today. I know I went a little over.